In this video, we're going to discuss slope-intercept form and why it's a helpful tool in making graphs of lines. So slope-intercept form looks like y equals mx plus b, where m and b are what's going to be changing out. M will be the slope, b is the y-intercept. So in this case, the slope-intercept form of a line is y equals 6x plus 4. We would say that the slope, the number that's in place of m, is 6. Or it'll be helpful later on to write that 6 over 1. And the y-intercept there would be 4. So let's take a quick second and practice actually writing slope-intercept form. We know we're trying to write y equals mx plus b. So let's say we wanted to write the slope-intercept form of a line with a slope of 2 over 3 and a y-intercept of 11. So here m is 2 over 3 and b would be 11. So slope-intercept form would be y equals 2 over 3 x plus 11. It's important to note that the x should not be in the denominator with the 3. It needs to be next to 2/3. That's 2 over 3 times the x value. Write the slope-intercept form of a line with a slope of -5 and a y-intercept at the point 0, -5. That's x is 0, but y is -5. So m, our slope, will be -5, and b, the y-intercept, 0, -5 tells me b is also -5. So we would write y equals -5x plus -5. But this looks odd. Plus -5 is the same thing as -5. So we would really want to write that as y equals -5x minus 5 would be the best way to show a negative y-intercept. Now we're going to use slope-intercept form to help us graph. Remember, slope equals rise over run. In order to do this, the first thing you actually want to do is put the y-intercept on the graph and then do the slope from there. So just kind of note number 1, plot the y-intercept. And then number 2, do the slope from that point. Okay, so in our case, y equals 2 over 3x minus 2. I would note there that the y-intercept, the b value, is -2. And the slope is 2 over 3. So the first thing we want to do is plot the y-intercept. The y-intercept is -2. So I'm going to put a dot on -2. Then the slope, 2 over 3, tells me to rise 2 and run 3. And we want to do that from the point where the y-intercept is. So starting at the y-intercept, I'm going to rise 2, then run 3. That's telling me to put another dot at this point here. We connect them, and that forms the equation of the line. So let's look at another example and try that again. Here we have the linear equation y equals -4x plus 3. The y-intercept is positive 3. The slope is -4. And I'm going to recognize that that's the same thing as -4 over 1. So let's start with the y-intercept of 3 and put a dot. We're putting a dot at 3, 0. So the y-intercept is 3. Now, to do the slope, -4 over 1. If you have a negative slope, you are no longer going to rise, you are actually going to fall. So in this case, we're going to fall 4 places. 1, 2, 3, 4 places. For the run, we're always going to run to the right. So we run 1 place, and we put a dot there. And now notice that that gives us that negative slope where you're falling down a ramp. Okay, so let's look at one last example of how we could do this. Y equals negative 4 over 3x plus 1. In this case, the y-intercept is positive 1, and the slope is negative 4 over 3. So we're going to start by putting a dot at 1 on the y-axis for our y-intercept of 1. The slope, negative 4 over 3, tells me I'm actually going to fall 4 places. 1, 2, 3, 4 places. And I'm going to run to the right 3 places. 1, 2, 3 places. We put another dot and connect them. And again, you can see we get that negative slope where you're falling down a ramp. Okay, now we're going to look at one where we're not given slope-intercept form. We're actually going to have to turn this into slope-intercept form. So we want to find the slope and y-intercept and then graph it. So what we really need to do is make it y equals mx plus b. We need to get the y by itself. So if I have 5x minus y equals 1, I want to get everything to the other side of the equation except for y. As we discussed in previous sections, you can move anything across the equal sign by doing the opposite of it. So I'm actually going to try and move 5x right here by subtracting it since it's positive 5x. I'm going to subtract 5x. And what I have is negative y equals negative 5x, and that was a positive 1. Now we want to remember, that is negative y. There is an invisible 1 there. That is negative 1 times y. To undo multiplication, we divide everything, both sides, by whatever that is. This would be y equals, and we have to divide the negative 5 and the positive 1. We have to divide everything by the negative 1. Negative 5 divided by negative 1 is actually positive 5. So positive 5x, and then positive 1 divided by negative 1 is actually a negative 1. And so now we can see the slope is positive 5, and the y-intercept is negative 1. So graphing that, the y-intercept is negative 1. And I'm going to note that this slope, right, is actually 5 over 1. That's telling me to rise 5 and run 1. So rise from that point, 1, 2, 3, 4, 5, and run 1. Tells me I'm going to have a dot right here. And there's my line, y equals 5x minus 1. So let's try that again, but now we've got 4x plus 3y equals 9. And we know we're trying to write y equals mx plus b. So we're trying to get y by itself. We've got 4x plus 3y equals 9. So the first thing I want to do is get this 4x to the other side of the equal sign. If it's positive 4x, we're going to subtract 4x. So now I've got 3y equals negative 4x plus 9. We divide both sides by 3. Y equals negative 4 is not divisible by 3, but that's okay because it's just a slope anyway. Negative 4 over 3x. 9 is divisible by 3. 9 divided by 3 is 3. So y equals negative 4x, negative 4 over 3x plus 3. The slope is negative 4 over 3. The y-intercept is positive 3. So now we can graph that. The y-intercept is 3. The slope is negative 4 over 3, telling me to go down 3, or sorry, down 4. Then run 3. We put another dot and connect them. The last thing I want to talk about in this video is parallel and perpendicular lines. What makes two lines parallel, or the fact that they will not intersect, these two lines would be considered parallel because they'll never intersect, is the fact that they have the same slope. Perpendicular lines have what we call a negative reciprocal. What happens with perpendicular lines, when they intersect, they form right angles. Well, what do we mean by negative reciprocals? A negative reciprocal means you flip the fraction and make it negative. So example, let's say we had 2 over 3. The negative reciprocal would be to flip that 3 over 2 and make it negative. The negative reciprocal of, let's say, negative 1 over 3, we would flip that 3 over 1, and since it was negative, it would become positive. So the negative reciprocal of negative 1 over 3 is 3 over 1, which is really just the same thing as saying 3. I want to recall the slope formula because it's going to be useful in identifying parallel and perpendicular lines. The slope formula is y2 minus y1 over x2 minus x1. So let's identify some parallel and perpendicular lines. For this example, determine whether the lines given by the pairs of points are parallel, perpendicular, or neither. So what we really need to know is the slope. So in this example, line 1 goes through 5, 4, and 3, negative 1. Let's figure out what the slope would be there. Where this is x1, y1, x2, y2. So to compute the slope, we would do negative 1 minus 4 over 3 minus 5. That's my y2 minus y1 over x2 minus x1. Negative 1 minus 4 is negative 5. 3 minus 5 is negative 2. Negative 5 over negative 2 is really the same thing as 5 over 2. So that's my line 1. Now let's look at line 2. Same idea. y2 would be 8 minus y1. Y1 would be negative 2 over x2 is 3 minus x1 is negative 1. We know that when we subtract a negative, we really add. So 8 minus negative 2 would be 8 plus 2 is 10. 3 minus negative 1 would be the same thing as 3 plus 1, which is 4. Well, 10 over 4 reduces to 5 over 2. So in this case, these are the same slope. So these lines are parallel. Let's look at our next example. Let's find the slope again of line 1. y2 would be 2 minus y1 would be 5 over x2 would be negative 1 minus x1 would be 1. 2 minus 5 is negative 3. Negative 1 minus 1 is negative 2. And we know a negative over a negative is really a positive. That's positive 3 over 2. So So that's the slope of line 1. Let's find the slope of line 2 now. y2 would be 1 minus y1 would be 3 over x1 is 6 minus, x2 is 6 minus x1 is 3. 1 minus 3 is negative 2. 6 minus 3 is 3. So we went from 3 over 2 to negative 2 over 3. We call that a negative reciprocal. These two are negative reciprocals. So we would say this is perpendicular.